Hello, all. Welcome to the day 4 of the daily case study series for Cbse grade 12. Today's question goes like this: Ramesh, the owner of a sweet selling shop, purchased some rectangular cardboard sheets of dimension 25 by 40 centimeter to make container packets without top. Let x centimeter be the length of the side of the square to be cut out from each corner to give that sheet the shape of the container by folding up the flaps. So the diagram is given. Based on the above information, answer the following questions. Subdivision 1. Express the volume V of each container as a function of x only. So V of x is equal to length breadth into height. The length of the container is 40 minus x on left and right has to be subtracted. So which gives us 40 minus 2x centimeter. Breadth is total breadth is 25. From that we need to subtract x and x, which gives us 25 minus 2x centimeter, and height of the container would be obviously x. So the expression is 40 minus 2x into 25 minus 2x times x. On expanding this, 1000 minus 50x minus 80x plus 4x square times x, which is 1000x minus 130x square plus 4x cube. V of x is equal to 4x cube minus 130x square plus 1000x. Done. Second one. Find dv by dx. So differentiating with respect to x, v dash of x, that is dv by dx, is equal to 4 times 3x square minus 130 times 2x plus 1000, that is 12x square minus 260x plus 1000. So this is dv by dx. Now subdivision 3, in that a part. For what value of x the volume of each container is maximum. So to get this, we have to make this v dash of x to 0. 12x square minus 260x plus 1000 is equal to 0. And dividing this by 4, 3x square minus 65x plus 250 is equal to 0. This can be factorized using the splitting the middle term. 3x square minus 50x minus 15x plus 250 is equal to 0. So we get 3x minus 50 and x minus 5 as the factors. X is equal to 50 by 3 and x is equal to 5. So now between the two values, I feel we can reject this 50 by 3, because when x is equal to 50 by 3, b becomes negative. B is 25 minus 2x. So if we substitute this 50 by 3 here, it goes negative. So we ignore x is equal to 50 by 3, and now the x is equal to 5 becomes the critical point. So at this critical point, we have to figure out whether we will get a maximum volume. For that, again, let's differentiate the volume function with respect to x. So v double dash of x is equal to 24x minus 260. Then v double dash of x at this critical point, x is equal to 5. 240 times 5 minus 260, which is minus 140. Since this v double dash of x is negative, x is equal to 5 is the local maxima. That is, the volume is maximum at x equal to 5. So that is the answer for third A. Third B. Check whether V has a point of inflection at x equal to 65 by 6 or not. So to figure out this, we have this v double dash of x, which is 24x minus 260. Let's put this. Let's put this in v double dash of x. That is, x is equal to 65 by 6 in the v double dash. 24 times 65 by 6 minus 260. On solving this, we get 0. Since this v double dash of x is equal to 0, this is the case of point of inflection. So when the second derivative becomes 0, the value that we have put for x, that becomes the point of inflection. So this implies x is equal to this 65.6 is a point of inflection. Let's meet tomorrow with another case study question.